Welcome to the HR Diary. In this video, I'm going to show you how to use Microsoft Excel to run descriptive statistics. Descriptive statistics is the first level of data analytics. Descriptive statistics answer what happened by describing or summarizing raw data. I will not only demonstrate how to run descriptive statistics with Excel, but I will also interpret each of them. Now let's get started. In my Excel sheet, I have some data in this column, and I want to run descriptive statistics on them. At the data tab, I have this data analysis function. This is a useful feature in Excel that many people do not know about. It is an add-on created by Microsoft to make it easier to perform statistical analysis. By default, you will not see this data analysis function. To activate it, you need to go to File, More, Options, Add-ins, and then at the bottom where it says Manage, select the Excel add-ins, then click Go. Make sure that this analysis 2-pack is ticked, then click OK. Now, when you go to Data, the Data tab at the top of the screen, you should see the Data Analysis button here. Now, we are ready to run descriptive analytics with this data analysis function. Click on this data analysis button, and you will see a range of data analysis tools. All right, from this list, look for descriptive statistics and click OK. For this input range, this is where you want to tell Excel the range of cells that contain your data. Click on the up arrow button here, and then highlight the data and hit enter on your keyboard. Next, you need to tell Excel how your data are entered in your sheet. If your values are in column, like what I have in this example, select group by columns. If your data are in rows, then select group by rows. Next, if you have labels at the top of your data, like what I have here, then tick label in first row. For the output options, here you have 3 output options: output range, new worksheet, new workbook. For the first output option, called the output range, you can enter a specific cell in the same worksheet where you want the results to be displayed. For the second option, new worksheet, it will display the results in a new worksheet. For the third option, new workbook, it will enter the descriptive analytics in an entirely new Excel file. Now, I want to have my results displayed in the same worksheet as my data. Hence, I will select the output range. So click on this. All right. And here is where I want to place the data. So I left click here and hit enter. Next, you can tick the various descriptive statistic analysis options that you want Excel to do. So here, tick the summary statistics. This will tell Excel to run the descriptive statistics. Also tick on the confidence level for mean and leave it at 95%. I will explain this in more detail later. K largest, tick it. This will tell Excel to display the largest value of your data. If you enter 1, Excel will display the number 1 largest value of your data. So in my data, the largest value here is 60. So if you enter 2, Excel will display the number 2 largest data. So in here, the second largest data is 40. So in this example, I will put in 2. Later, you will see that the K largest will return 40, which is the second largest data. And for K smallest, you tick this if you want Excel to display the smallest value in your data. So if you enter 1, Excel will display the number 1 smallest value of your data. If you enter 2, Excel will display the number 2 smallest value of your data. In this example, I will enter 2 for K smallest. This means I want Excel to display the second smallest number of my data. Now that the setup is done, let's press the OK button to get Excel to run the descriptive statistics. Okay, let me adjust the screen. All right, as you can see, Excel has generated my descriptive statistics here. I will now go through each one of these in detail. Let me unhide some things that I have prepared here. All right, mean. What does mean means? So the first result is the mean, or what we call the average. Here, you can see the formula here. This is the formula to derive the mean. Here, the mean value is 39. And mean, the definition is mean is the sum of all the observations divided by the number of observations. That means you add this up and divided by 5. And this is how you get the 39. Next, standard error. So here, as you can see here, this is the Excel formula to derive the standard error. Here, my standard error is 6. Standard error are expressed in the same units as the data and the mean. Standard error measures how well a sample represents the population. The higher the standard error, the higher the variability. When the sample is representative, the standard error will be small. Standard error decreases when sample size increases. Unfortunately, there is no intuitive interpretation of how big or how small a standard error value is. However, the calculations for confidence intervals here, the bottom one, incorporate the standard error, and this confidence level is much easier to interpret. So for these descriptive statistics, I would recommend that you focus on the confidence interval and don't worry too much about the standard error. The next descriptive statistics is the median. And this is the Excel formula to calculate the median. Median is the middle number in a sorted list. So if these numbers are sorted, the middle number is 35. And that's where you get 35. Next is the mode. This is the Excel formula here to derive the mode. Here, The mode is 35. Mode is the observation that appears the most frequently. As you can see in my data, 35 appears twice and it appears the most frequently. Next is the standard deviation. And this is the formula, Excel formula. If you want to calculate yourself, this is the Excel formula to derive the standard deviation. Here, the standard deviation from the mean is 13. Standard deviation tells us the average distance that a value lies from the mean. Standard deviations are expressed in the same units as the data and the mean. Standard deviation is useful when you are comparing the spread of two separate data sets that have around the same mean values. A low standard deviation indicates that the values tend to be close to the mean of the set, while a high standard deviation indicates that the values are spread out over a wider range. Standard deviation is one of the key methods that analysts, portfolio managers, and advisors use to determine risk. Securities or stocks that are close to their means are considered as less risky investment, as they are more likely to continue behaving as such. Variance. Variance helps you to determine the size of your data spread. This is the formula here, all right? Is the Excel formula to derive the variance. In my example, the variance is 68. The more spread out the values in your data set, the higher the variance number. As variance is a squared quantity, it is difficult to use compared to standard deviation because variance is not using the same units as the data. Standard deviation is a more useful measure. Standard deviation here is a more useful measure of spread and is much more widely used than the variance. In our example, our sample has a mean of 39 with a standard deviation of 13 or 168. Ketosis. Ketosis is the measure of the flatness of the distribution. Let me pull out this kurtosis. All right. So kurtosis is a measure of the flatness of the distribution. A normal distribution, which is this line, has a kurtosis value of 0. A positive kurtosis here indicates a relatively peak distribution. A negative kurtosis indicates a relatively flat distribution. So I have put in the formula here, right? So this is the Excel formula to derive the kurtosis. In my example, the kurtosis is 2, which means it is a relatively peak distribution. Here is a peak distribution. Okay, let me move this away. Next, skewness. Skewness is a measure of the symmetry of data distribution. Okay, let me show you here. Skewness. So a value of 0 here, skewness, indicates a perfectly symmetrical distribution. Positive skewness means positively skewed. Negative skewness means negatively skewed, which is this shape. And this is the formula here. Is the formula to derive the skewness. Here, the skewness is 1.23, which is positive. This means is positively skewed. All right. Let me hide this. Next is the range here. The range. Range is the difference between the largest and the smallest values in the data spread. The bigger the range value, the more is the spread of the data. This is the formula here to derive the range. In my example, the range is 35. Next is the minimum. Minimum is the lowest data value of the data set. And this is the formula to get the minimum. So my minimum is 25. As you can see here, the lowest number is 25. Maximum. Maximum is the highest data value of the data set. And this is the formula to derive the maximum. Here, the maximum is 60. As you can see from this data, the biggest number is 60. Next is the sum. Sum is the total of all the values in the data set. And this is the formula to get the sum. Next is the count. Count is the number of observations in the data set. Number of observations, or what we call number of items. So here I have 6 observations. I have 5 observations. So here I have 5. And this is the formula to derive the count. K largest. K largest displays the largest value of your data. During the initial setup, I entered 2 for K largest. Remember here? Right? For K largest, I entered 2. This means I'm asking Excel to display the second largest number in my data, which is 40. In this data, the second number biggest is 40. So I entered 2, and that's why it displays 40 here. Next, K smallest. Let me go to K smallest. All right. K smallest display the smallest value of your data. So during the initial data analysis setup, I entered 2 for K smallest. This means I'm asking Excel to display the second smallest number in my data, which is 35. And that's why it displays 35 here. Confidence level. The last item is the confidence. Here, this is the confidence interval value, this 16. Right? This is the value that you can add and subtract from the mean value to calculate the upper and lower 95 confidence levels respectively. If we input 95% in the confidence level and the generated level 95% and the generated level is 16 here, it means that there is a 95% chance that the values fall between negative 16 of the mean and positive 16 of the mean. All right. Okay. All right. That's it. I have shown you how to calculate and how to run descriptive analytics, descriptive statistics with Microsoft Excel. And this is the descriptive statistics that Microsoft Excel ran for you using this data analysis tool. I have also shown you how to run the descriptive analytics, calculate it using Excel formulas. And these are the formulas that you can run. And I've also explained with all this how to interpret all these descriptive statistics numbers. I hope that you found this video useful. Don't forget to like, share, and subscribe to the HR Diary channel. Thank you.